So another example with expanding a binomial expression. I would like to point out in terms of this being slightly different than some of the nicer examples at the beginning. You have something slightly more complicated than just a single variable as the first term. So just kind of keep that in mind. Our first term in our case is a 4x. And our second term, also slightly more complicated than just a single variable. We are looking at the second term equaling, I think it's a 5y. And what we can do for ourselves, actually, if it's helpful, we could look at this as, and this might actually save us a little bit of trouble, 4x minus 5y is the same thing as 4x plus a negative 5y, still all taken to the 6th power. So it could be useful, if you would like, to include the negative sign in that second term, so that when we go through raising these terms to powers, we actually take care of the negative sign in this particular expression. So if you're going to start off, it might be useful to understand the coefficients first. So again, I will kind of write out my ideas. I have 4x minus 5y, and I'm taking this to the 6th power. Now, as far as the formula would go for binomial theorem, it's more of a pattern than something that you have to memorize. So I'll write it out for the purposes of notes. Keep in mind your power that you're trying to expand this binomial out to is a 6. So when you start off, you'd be looking at this as 6 to 0. Now the first term, which is 4x, it's always going to be taken to the power of the binomial. So in this case, it's 4x to the 6th. We will not have a y term. If you'd like, you can include it. But we remember that the powers of the terms always have to add up to the n. And what the n is the 6. So that's the idea of the first term. Now we can add. Same idea, we'd just be taking, again, it's a pattern. 6, choose 1. Take your first term, 4x, and we're counting downwards from our previous, so it was previously x to the 6, 4x to the 6, so now it's 4x to the 5th. And now what you're going to do with your y term is start counting upwards, so 0, 1. And again, please remember, if you're confused as what powers to take, they always will add up to your original power, 6. Keep going. We should have 6, choose 2. We will take our 4x, raise it to the 4th power, our negative 5y, raise it to the power of 2. And reminder, they add up to 6, the power that we started with. Keep going. It's more of a counting game. We have 6, choose 3. So we end up saying, okay, that's 4x to the 3rd power. And negative 5y also to the 3rd power, because we're counting upwards, and the fact that we do have to make sure that they're adding up to 6. A little bit more to go. Takes a little bit of horizontal space. Sometimes I turn my paper the other way, but I guess I have unlimited space when I'm using this one. So I have 6, choose 4. Take the 4x, that's the first term. And it was a power of 3, so we're counting downwards. We're going to raise it to the power of 2. Take the negative 5y, we're counting upwards. We're going to raise it to the power of 4. Again, making sure they do add up to 6. How do we know when we stop? You will see right away. 6, choose 5. We're going to take 4x. It's technically to the 1st power. Negative 5y will be raised to the 5th power. Again, adds up to 6. Looking good. So now we have 6 choose 6. That's how we know we're ending, by the way. But you will also kind of see it in your powers of x. Notice there's no more powers of x to take because technically it's 4x to the 0 power. But the final power of the second term, negative 5y, will be the same as your original power that you started with. Again, making sure that they add up to 6. So I know for sure I'm done when I've dealt with the 6 choose 6 term, or at the end where I have no more variables from the first term, and I have only the second term raised to the exact power I see on the original binomial. So this is a nice pattern to go with. Now, if you're interested in figuring out what are these particular coefficients, you can take Pascal's triangle. I'll kind of take my time on this one. But really, we're starting out with 1, 1, 2, 1, 1, 3, 3, 1. Then just adding the terms above with ones on the very edges of the triangle. So 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And now I kind of see I'm at my 6th power right here. Maybe I'll do that in red again to make this stand out. So 1, 6, 15, 20, 15, 6, and 1. So that should be the chosen row. So all of the choosing parts, 6 choose 0, my friends, is equal to 1. If you prefer, you can now start simplifying as you go. And this might need the use of the calculator. If you have 4x to the 6th, you're going to have to raise 4 to the 6th power, and this would involve probably using a calculator. These are kind of large numbers. So keep in mind, I'm not really doing this in my mind. I'm using my TI. So I'm getting 4,096 times x to the 6th. And I do not have to write my negative 5y to the 0 term because that's equal to 1. Now, same story. You guys want to check what 6 choose 1 is? Just go to your Pascal's triangle. You're going to get a little dizzy here, but we do have a 6. And the matter is just making sure you're keeping track as you write them down. So if you'd like, because we keep scrolling back and forth and I don't like making people dizzy, I could replace all my 6 choose 1, 6 choose 2. 6 choose 2 is 15. 6 choose 3 is 20. 6 choose 4 is another 15. 6 choose 5 is 6. And 6 choose 6 is another 1. That way we don't have to keep scrolling back and forth on that. So now I've got my coefficients taken care of. Now it's a matter of just simplifying your powers of your terms. So now if we're going to take this, we may need a little more space. But if we have 4x to the 5th, again, we're raising 4 to the 5th power. So that would leave me with 1,024 x to the 5th. And now I need to multiply this by negative 5y to the 1st power. So that's, again, just negative 5y. That's added to 15 multiplied by, now we're going to raise 4x to the 4th. So 4 to the 4th is 256. Let's color code that a little nicer for you. 256x to the 4th. Now if we want to raise negative 5y squared, we need to be really careful because we do have a negative sign raised to a power. So when you raise a negative symbol or a negative number to an even power, we will get a positive term back. So 5y squared, 5 times 5 is 25y squared. We're adding. We have 6 choose 3, that's the coefficient of 20. 4 to the 3rd power is 64. So we should have 64x cubed. Now, again, be careful. You are raising negative 5 to the 3rd power. It's actually negative 5y cubed. So a negative number raised to an odd power is negative. 5 cubed, 5 times 5 times 5 is 125. So we don't forget the y cubed as well. Add this on, we're almost there. It seems a little tedious at first, but a lot faster than having to FOIL this guy out. All right, so 4x squared, that's very nice. I have 16x squared. Now negative 5y to the fourth. I do realize it's going to be a positive number. So 5 to the fourth, I'm just saying 625. Now I'm getting y to the fourth. Let's make that 5 a little nicer, especially if we're referring back to it. This is again added. 4x to the 1, we don't have to do much. But negative 5y to the fifth, again, keeping in mind that we do have a negative number. So 5 to the fifth, that is 3,125. Don't forget the y factor as well. And now 4x to the 0 power, we don't have to deal with because that's equal to 1. But negative 5y to the sixth, we do have to take account for. It should be positive, negative number raised to an even power. And 5 to the sixth, a quick punch in on my calculator. I'm getting 15625 y to the sixth. So I encourage you, if you are utilizing the binomial theorem, show this part first. I know it looks a little intimidating, but it really is just a bunch of numbers that you can definitely compute using your calculator. This would allow, if the teacher is grading some partial credit, it gives you some explanation of why you're getting the answers you're getting. But at this stage, now all we have to do is just find the product of all the factors. So we should finally get 4,096 x to the sixth. The next term, kind of keep in mind what we're looking at. I know it's plus, but check out your numbers. 6 times 1,024 times negative 5. Definitely use your calculator. And because you're getting a negative number, that's where we're getting the minus sign from. So I'll exaggerate that a bit. So the product of all the number factors, 30,720, and then just take account with your variables. We should have x to the fifth times y. Next term over, we do know it's positive, but now we'll be multiplying 15 to 56 and 25. I don't know if you hear me punching it in my TI, but that's exactly what I'm doing. I should get 96,000. It's quite large. And then keep in mind you have your variable factor, x to the fourth y squared. Now the next term, you're probably getting the pattern already. There's alternating signs. We do have a negative or minus, and we'd be multiplying 20 by 64 by 125 to get 160,000. Don't forget your variable factors, x cubed, y cubed. The next term will be plus, mainly because we recognize the pattern, but we also recognize positive times positive times positive. I'm looking at 15 times 16 times 625, and that's giving me 150,000. We're having quite a fun time with these large numbers. And that's going to leave us with x squared y to the fourth as those variable factors, plus a negative. Positive times negative, that makes that minus. I'm looking at 6 times 4 times 3,125. That's leaving me with 75,000. And I have x times y to the fifth. And finally, the very last term is positive 15,625, and we have y to the sixth. So I'll shrink this down so we can see this all in one shot. If you need to move to the next line, just be really careful as you're eyeing this. Just look at what we have. Our final expansion, we end up having 4,096 x to the sixth minus 30,720 x to the fifth y plus 96,000 x to the fourth y squared minus 160,000 x cubed y cubed plus 150,000 x squared y to the fourth minus 75,000 x y to the fifth plus 15,625 y to the sixth. That is a lot of things to say out loud, but I hope it helps with showing the work of why we're getting our numbers. And I hope you find value in using this expansion. This is a lot less foolproof in terms of, or should be more foolproof, is that you won't make minor mistakes if you're trying to multiply things out using distribution or FOIL. So I hope this helps. Take your time on these. There are other ways to find the coefficients. Maybe we'll try that in the next example. I will see you then.